Premium Hill Academy. Morality, ingenuity, and excellence at its peak.
Welcome back, guys. Today we'll be looking at determinants of matrices. In the former classes, we talked about matrices and how they are applied, right? But in today's class, we'll be looking at determinants. And we'll be starting with the 2x2 determinant. What is a 2x2 determinant? Right? So we said determinant of a 2x2 matrix. You know what a 2x2 matrix is now, right? It's when we have 2 rows and 2 columns. So determinant of a 2x2 matrix is denoted by this. We put a bar. So if we have A as our A, B, C, D, this is our matrix form, right? This is a matrix, right? If you want to convert this to a determinant, it becomes A, 2 bar here, and this curved bracket becomes a straight line. A, B, C, D. This is how a determinant is denoted by. It's not a determinant. Right? This is the difference between a matrix and determinant, is that the matrix has a curved bracket, but the determinant has a straight bracket. Right? And the main determinant is denoted by this, or a det, a det A, stuff like this now, or a det A. I will say which also means this. That's what I just explained to you. And now the idea behind a 2x2 matrix is that we take the difference of the product of the element diagonal. What do I mean? We are taking the difference. The word difference there means to minus, to subtract. We are subtracting the element diagonals. That means we are multiplying. See, they said the element diagonal starting from the principal diagonal. So look at now, we said is that we take the difference of the product. Underline this word, difference of the product. The difference of the product. So what do we mean by that? It means these diagonals will multiply themselves, right? So we can say A becomes this times D. That's A times D. That's not the product. And we're taking the difference minus this one, right? Minus C times B. That's all about determinant of 2x2 matrix. And we see, remember what we said? We said it is starting from the what? From the main or the principal diagonal. Starting from the main or the principal diagonal. So look at the main diagonal. That's why we're starting with this one first. This one is known as the main diagonal. So you can come here and see the main or principal diagonal. Right? I hope you can see what we're doing. So if we are doing the 2x2 matrix, it must start from the main diagonals. These two must multiply minus these two will multiply. Let's take for examples, for instance. So for example, we have if matrix A is 3, 6, 1, 2, find the determinant of A. So if this is a matrix, the determinant that is 3, 1, 6, 2 becomes what? That is A, expanding A, it becomes 3 times 2, because we said I'm multiplying the what? The main or principal diagonals first. That's 3 times 2, 3 times 2 minus what? Minus the other diagonals, minus 6 times 1. Right? So that becomes A as what? 3 times 2 is 6, 6 times 1 is 6, that is 0. See now, therefore, our determinant or this or det A, small letter, we use a small letter, det A becomes 0. Right? That's as easy as it gets. Whenever we're doing 2x2 matrix, what we do is just to take the product of the principal diagonal minus the other diagonal. So this is the principal diagonal minus the other diagonal. That's as easy as it is. That's all about the 2x2 matrix. I'll give you 2 other questions to buttress what we just did, so we can have clear understanding of what we are doing. Follow me, guys. Welcome back, guys. Let's look at the question we have on the board. It says if Q, that's this matrix, is equal to this, so find the value of X from the determinant. That means first of all what we do is to change this matrix to a determinant, right? So let's answer question A. The solution A becomes this is the question that Q is equal to X plus 4 and X. Here we have X plus 1 and x minus 1 equal to 2. So doing the determinant of this, it will be q equal to what? X plus 4, because you're looking for determinant. X plus 1, here is x and x minus 1, which is equal to 2. So what do we do from here? First of all, we said in solving determinant, in simplifying determinant, the principal diagonal must multiply, right? So we have x plus 4 times x minus 1. Therefore, q becomes x plus 4 times x minus 1, right? So this is the first one we do, and then minus what? Minus this one. So minus x plus 1 times x. And that's how it works. So what do we do from here now? We'll try to expand this bracket so that q becomes x times x, which is x squared, x times minus 1, which is minus x, 4 times x, which is what? 4x, and what? 4 times minus 1, which is minus 4, right? We're done with this. Then we'll move to this minus x times x will multiply everything. X times x, the x squared plus x times 1 will be x. So what do we do next? We open this bracket, right? That's the next thing we do. By opening the bracket, q becomes what? Let's try and open the bracket by using this minus to multiply everything inside. So minus times invincible plus becomes minus. So let's just try and open the bracket. Q becomes x squared minus x, right, plus 4x, right, minus 4. Now minus times x squared becomes minus x squared, right, and then minus times plus becomes minus x, right? See how easy it is? All of them is equal to 2, please, because we have an equal to 2 here. That's equal to 2 as well. Sorry about that. So let's try and simplify further. We'll collect like terms. By collecting like terms, what do? It becomes x squared minus x squared. I'm seeing 2x squared here. X squared minus x squared minus x plus 4x. What is minus x again? Right? What is again? I'm seeing minus 4 equal to 2. Right? I'm sure you understand what we're doing. I'm just trying to make it a bit faster so you can understand what we're doing. X squared minus x squared is 0. Right? Minus x plus 4x minus s becomes what? Let's look at that. Let's use that our number line system we do. Right? So minus x is x plus 4x, 1, 2, 3, 4, minus x again is x. Right? So what happens? This 2x will take off 2x from here. I'm left with plus 2x. So minus x plus 4x minus 2x give us what? 2x, right? Minus 4 equal to 2. I'm sure you understand what we're just doing. I hope you understand what we're doing. But that's not all. What we'll do is now we'll collect like terms. Collect like terms. Why we collect like terms? Because this and this cannot add or subtract. So I have to take this 4 down to where this 2 is. And if we move this minus 4 down, it becomes plus 4 here. So we're left with 2x is equal to 2 plus 4 here. So that our 2x becomes what? Becomes 6. Divide both sides by 2. 2 we take off 2. Our x becomes 6 divided by 2 should be what? Becomes 3. That's the value for x. But that's not what we're asked to find. We're asked to find the value of x. We're done with x and from the determinant. So we're done with question 1. Question B says we should construct the matrix from the determinant. So let's look at how to tackle question B question. Question B should construct the matrix. It's not hard. It becomes very simple. If you are done with if you have gotten a value of x, it's just to fixing the value of x in the matrix equation. So from that it becomes what? Our q becomes what? It becomes which has x plus 4, right? X and then x plus 1 and then x minus 1 here. If we are fixing the value of x, it becomes q will give us x here becomes 3, right? 3 plus 4 and then what? And then 3 plus 1. Here we have 3 and then 3 minus 1. Right? If we complete it, our q becomes the matrix. The original matrix becomes 7, 4, 3, and 2. That's the value of B. That's what B is asking us. Question B is asking us to do. He said we should construct the matrix from the determinant, and we found the determinant as this, having our x. So we're just fixing the value of x and then construct the matrix. This becomes the matrix. If we want to change this to determinant, it's just to make this line straight and put a straight line here. Right? It's that simple. But then question C is saying that we should show the proof of the answer. How do we show the proof of the answer? We'll take it back to determinant if we want to show the proof. Right? The proof is that we want to show that this answer here is equal to 2. That's all. We want to show that this answer we have, or this answer we have, this determinant answer we have, is equal to 2. If we solve for the determinant, that's remember we have already arranged this. We have already known the value of x in this determinant. If we fix the value of the whole determinant and we solve for the determinant, if it is equal to 2, then it's correct. If it's not equal to 2, then we're not correct at all. So let's show that this is equal to this. That's the proof they're asking us to do. Show the proof of the answer. So from here, if we have our determinant as 7, 4, 3, 2, it's just to multiply, right? To multiply the principal diagonal face. So 7 with times 2, so it becomes 7 times 2, right, minus what? 3 times 4, minus 3 times 4. So 7 times 2 is what? Is 14. 3 times 4 is 12. And that gives us, you see, it's easy now. Our answer there is 2. That's the value for C, the answer for C. Everything here is equal to 2, and that's the proof. We've gotten our value for x and substituted x for the question, and then we solve them to get the original matrix. If we change it to our determinant and try and take or simplify it, you see that this answer will give us 2, which is equal to this 2 here. That's the simple proof of what we've just done. I'll be giving you another question to expand your understanding of what we just did. In case you still find this a bit confusing, I'm going to show you yet another question to help you understand how 2 by 2 determinant matrix works. I'll see you guys. Alright guys, let's look at the question we have on the board. It said if determinant of 3957 is equals to minus 84 minus 4x, to find the value of x, and then we should show the proof of the question given. So let's look at the solution of this. Solution A. Let's look at how it works now. This, we have 35 as determinant, 97, right, is equal to what? Minus 8, 4, minus 4, and x. So what do we do with this? We simplify further by taking the principal diagonal first. That will be 3 times 7 minus what? 5 times 9. Right? Which is equal to the same thing with this. We take the principal diagonal first, minus 8 times x, minus 8 times x, then minus what? Minus 4 times 4. Right? So in doing this, we have 3 times 7 is 21, minus what? 5 times 9 should be what? 45. Right? Is equal to minus 8 times x is minus 8x, minus times minus is what? Is plus 4 times 4 is 16. See, we are already constructing a simple equation from here. So 21 minus 45 what? Will be minus 24. Right? Is equal to minus 8s plus 16. So what do? We collect like terms because these two cannot add. This one has an alphabet x, this one doesn't have. So what do we do? Look at, I can show you a simple way of how we can do this. We can simply take this minus 8s, bring it here, it becomes plus 8x here, right? And we can take this minus 24 and replace it here, it becomes what? Plus 24, right? Let's see what we mean. If I bring this one out, it becomes 8x is equal to what? If I bring 24 in, it becomes 24 plus 16, right? That's plus 24 plus 16. The plus is not shown here because it's an invisible plus, the same thing, right? So now we have 8x is equal to 24 plus 16. That should be what? That should be 40. What we do here is we divide both sides by 8. That's the coefficient of x. So it becomes 8x equal to 40 dividing both sides by 8. right? And so 14 divided by 8 should be what? 5. Therefore, x is equal to 5. You see how easy it is now. What's the value of x? Well, question number B is saying we should show the proof of the question given. What does it mean to show the proof of the question? We are asked to show that this portion is equal to this portion. That means if we solve this portion, the answer we get from this part of our determinant must be equal to the answer we get from this determinant. Remember, we found the missing number x. So if we fix it now, that's for question B. And for solution B, it's going to look like this now. We're going to have 3, 5. Here is 3. Here is 5. Here is 9. Here is 7. Equal to, that's our minus 8, minus 4, and then 4. Instead of x, I'll put here, we've already gotten the value for x. So it becomes 5. See how easy it is? So for us to show that the answer is equal, what we do is to look for the determinant of this question, this part of the question. Also look for the determinant of this part of the question. The answer we get here, if it's equal to the answer we got here, it shows that the proof is correct, right? So what do? We start by expanding it, and we do it from the principal diagonal, right? 3 times 7, so it becomes 3 times 7 minus what? Minus 5 times 9, or 9 times 5, depending on what you choose. Minus 9 times 5 equal to this part of it now. We have minus 8 times 5. It becomes minus 8 times 5. So minus minus 4 times minus 4 times minus 4 becomes 16. Right? So I can just easily push minus 16 here. Right? Okay, that's simple. Minus 4 times minus 4, that's minus 16 there. So I just succeeded in doing that, but let's just finish it off. 3 times 7 being 21, 9 times 5 being what? 45 is equal to 8 times 5 being what? Minus 40. Minus times minus there is plus. Then we have what? We have 16. See how easy it is now. And so from here, what do? It becomes 21 minus 45, which is 24. That's minus 24. Because 21 minus 45 will give us minus 24. Right? Also, minus 40 plus 16. With your calculator, you will discover it's also minus 24. So this part of the question is equal to this part of the question, shows the proof of this question given. So from the beginning, we started our question by finding the value of x. Having got the value of x from the broken down steps, we were asked to show the proof of the question. I told you that for us to show the proof means that if we expand the determinant of one portion of it, and the answer of it is equal to the expansion of the determinant of the other portion of it, and both of them are equal. So that's what we just did. So with this and this, expanded the determinant. Also, we expanded the determinant. Looking at them, both of them are what? Are minus 24. Right? I'm sure you understand what we just did. So in case you don't understand, we still have one more question to expand your understanding on what we just did. See you in the next class, guys.
Premium Hill Academy. Morality, ingenuity, and excellence at its peak.